So this is just a few definitions and some examples that I included in your folder for today. And it might be helpful to have this in a tab, or if you have a printer, you can print it out. If you don't have a printer, no big deal. These are some of the definitions we're going to be working with as we look at other types of functions beyond linear. And all of these are a family of polynomials. And the key with a polynomial function, what makes them all related to each other, is the fact that they have integer powers. They're raised to an exponent, but they're non-negative and they're a whole number. So when we look at different polynomials, that's one thing to pay attention to. The other thing too is that if we write polynomials, typically we write them in standard form, and the standard form of a polynomial is just where we write the different terms in order of the highest exponent first, and then terms descend from there. So that way it's pretty easy to know what kind of polynomial you're looking at if you just look at the first term, but you want to make sure that those are written in standard form. Sometimes in examples they might not give you that. The thing that we're going to focus on and use terminology for is the idea that when we talk about how many terms are in a polynomial, that has some significance. But the other thing that tells us a little bit more about the graph of the function and the behavior of it is its degree, which is the power that we're looking at. So what we're going to look at is the special names that we give to polynomials based off of their degree and perhaps how many terms they have. The number of terms really doesn't tell us much about the graph, but their degree certainly does. So if we take a look at a few examples, I just want to talk about the degrees here. And so if we start with the first one and we just think of constants, if you had 7 or -2 just by themselves, you did y equals, that would be a horizontal line, and constant functions stay the same. They're 7 all the time, or -2 all the time. Linear functions we studied a lot of, and that can be just an x to the first power, and so it has a slope to it. This is a consistent slope. It's a straight line, and you could have something like x plus 2 or 7x. Those are all examples of linear functions. We've dealt with lots of those. Quadratic functions are the next level up, right? So x to the second power is anything with an x squared is a quadratic, if that's the highest degree term. And so we're going to be looking at quadratics specifically in the next unit. And then we'll continue on beyond that. So obviously, if you have an x to the third, that's a different type of function, and that's a cubic function. And you could have an x to the fourth. That's what we call a quartic function. These all have different types of graphs, and they behave differently as we plug numbers in for x. And so we're going to study a little bit about what's different and what's the same about each of these polynomial functions a little bit later on in the course. A quintic is really just a 5th degree polynomial, and again, notice I wrote all of these in standard form where the highest degree term is first, and then we can generalize this, that we would say an nth degree polynomial is anything that has x to the n power. So you could, after the names after quintic, there's not a special name, so x to the 6th we just refer to as a 6th degree polynomial, x to the 7th is a 7th degree, and so forth. So they don't have special names like the first 5 types of functions. The other thing we want to pay attention to is the structure of the polynomial. So if it's a mononomial, generally it just has one term, and what you're looking for in the terms is addition, subtraction. So here is an example of a binomial. And sometimes we look for structure in polynomials, like are they binomials or trinomials? A trinomial clearly has 3 terms to it, and so you can see those 3 terms are separated by addition or subtraction signs, and again these are in standard form. And then a polynomial, an example of 4 terms would be something like this: x to the third plus x squared plus x plus 1. So that would give us 4 terms, and then clearly anything beyond that, again, they don't have special names like mononomial, trinomial, binomial, that we just say this is a polynomial with 4 terms. So then you'd know that there are 4 different pieces to the the structure of it. Okay, so on the second page, it is just again a different look at some examples. And if we look at the definition of a polynomial function, again, that's kind of the basic structure of it. And the number in front we call the coefficient, and you heard that before as we go through there. And so just keep in mind that the numbers in the exponents are whole numbers. So we have non-negative integers, and we have coefficients in the numerator that are whole numbers. Okay. The other thing to keep in mind then, here's some examples. So for instance, look at that example 6. It's a 0-degree polynomial and it only has one term. So we would call it a monomial, but it would be constant. And so if we look at the next one, linear, it's a 1st-degree polynomial. If we look at the next one, 3x squared, notice that that's a 2nd-degree polynomial, so that's a quadratic, but it only has one term, so we consider it a monomial. The next one down, notice, is a cubic because it's x to the 3rd. It's also a trinomial because it has 3 terms to it. And then the next one we have is a quartic, and that has a value of x to the 4th, and so, but it only has 2 terms, so this is considered a binomial. And then the last one, notice that it is x to the 5th. It's a quintic, and so when we look at quintic, remember that that's going to be 5th degree, and we have that one that looks, and it has 4 terms, so we would consider it a polynomial of 4 terms. And then last two, a couple of things to keep in mind if you're just looking at different parts of the polynomial. We call the leading coefficient is the highest degree polynomial. This polynomial would be considered a cubic because the highest degree is a 3rd degree term. And notice it has 4 terms, and we've just pointed out the different terms, the cubic term, the quadratic term. We would consider this the linear term, negative 2x, and then the constant term with that. So as you're exploring the couple examples, we just want to know what the pieces are to each of these, and that'll give us a good start for identifying the different parts of functions.